So there is a method called interpretive structural modeling, though the name some may sound to be quite confusing or maybe a little bit difficult, but it's a relatively simple thing which I have found the managers can really implement this in practice well. And if you see in this table, you see some symbols here, A, V, X, and O. So V means risk I impacts risk J. So if you look at the first row, you will see production variability is impacting input price volatility. So that's why it is indicated as a V. That means risk I is impacting risk J. If it's the reverse relationship, if you go to the column, you will see the same way. Production variability column, you will see an A with input price volatility. That means it says that input price volatility, it sort of gets affected by production variability. And then X means it's a both-way relationship. Managers are not really sure. It can happen both ways. It's production variability and inadequate safety standards. Maybe because of inadequate safety standards, production variability happens. And because production variability happens all the time, maybe government has not really created adequate safety standards. So it can be both ways. And O means there is no relationship between the risks. They seem to be quite independent of each other. The managers, experienced managers working in this industry for many years and actually experiencing this risk can do this exercise reasonably accurately, though it might take some time, but they have a fair understanding which risk might impact which other and so on. So this is the first step of the process. We try to understand how these risks might impact each other. Once we have done that, then we obviously like to convert these to some numbers so that we can prioritize and have some more concrete actions. So what I will do next is that we convert these symbols V, A, X, and O to sort of 1 and 0. So all the V's and X's will be converted to 1 and A and O will be converted to 0. So that's what I do in the next table, and you will see this, and the diagonal elements will obviously also be 1. And in the end, you see a driver power and a dependent power. So the dependence power is the sort of the row sum, and the column sum, and the driver power is the row sum. So if you see in the first row, you see 1, 2, 5, and 6, and so that becomes 1. That becomes the driver power. You add up all the ones in a row. That becomes the driver power. You add up all the ones in columns. For example, for inadequate safety standards, it is 5. For lack of traceability, it's 2, and so on. So what it essentially tells is how many risks is impacted by one particular risk. So production variability, how many risks it is impacting. So that becomes its driver power. It obviously includes itself. Similarly, dependence power means how much one particular risk gets impacted by other risks. So the dependence power for production variability is 4, including itself. That means it is getting impacted by 3 other risks. It's a very simple calculation. It's based on managerial judgment of which risk is impacting each other, but it has a very interesting insight in terms of driver and dependence. So driver means the more the number of risks one particular risk impacts, that means it has it is something which the management should clearly take notice of and probably prioritize, because this particular risk is impacting many other risks. So if I need to take some mitigation action, I will probably take actions on the ones which is having an impact more on other risks. So and that's what you see here, the total number of risks which may be impacting. And I create a 2x2 matrix, which is a driver and dependence power map. What you see here is the driver power in the horizontal axis and the dependence power in the vertical axis. What you see as the different numbers are the risk categories which I had shown you before. So instead of naming them, I had put them the actual numbers here. And you see some risk in sector 2, where the risks are driver powers are high, and some in sector 3 where the dependence powers are high. That means these are the ones which are getting impacted by others, and driver power high means these are the ones which is impacting other risks. And you have something in the bottom, sort of sector 1, which is somewhere in between. So they are sort of the risks which gets also impacted by others, and they also impact others. Now this is also insightful. As I said, high driver power means these are the risks which are impacting some other risks, so I need to really take action on this. If I take action on this, probably I also reduce the effect of some of the other risks. But this may also get a little bit confusing. There are so many different risks. Can we see some pattern here? So if I look at this, then we try to create some clusters, and we clearly see there is some patterns. Some of the risks which have high driver powers are supply dependency and contracting related, the example which I'm giving you. And let's take an example of that peanut butter case. If a company like that has to do this exercise, they should have done a process like that where you're explaining. They should have identified the risk. They should have also understood the interrelationship between the risk, and then suppose now they have to prioritize. This is insightful for them. Okay, there are some problems related. We are probably dependent on some critical suppliers, and if something happens to them, it is risky. We do not have really very strong contracts with them. Suppliers do not are motivated enough to make some improvements. We also see some supplier variability, visibility, and traceability related risk. So we don't really know what is going inside our products. We don't have full traceability. There are some variability in supply processes. Excuse me. We don't have full visibility of what is happening in the suppliers, their financial health, their manufacturing processes, and so on. And there are maybe some internal manufacturing disruption. So this is also insightful. So when I look at the dependence between the different types of risk, and we also see some clearly identified categories that these are the ones which we may need to look at. So this is the first step. Doing the driver and dependence analysis, doing what extent each risk are related to each other. The next step is what is the utility of these processes, which I'm not completely showing here, but you can actually create a risk tree or a risk diagram. You can find out which are the risks at the bottom, which is impacting the risk at the next level, and then those risks together impact the risk at the higher level. And we can create a risk tree or a risk volcano, which I'm saying, so we can really understand this hierarchy between the different levels of risks. That's also very important for managers. I've seen that. So now they really know which are the risks at the bottom, which are really causing all the other risks. So it's important to know that. You can also quantify it, though it's again based on managerial judgment, but they can say whether this impact is sort of high or low or medium. They can try to put some numbers. And if they also have the performance measures, which as I've shown you in the example, they can also find out maybe what extent one particular risk is impacting, say, revenue growth and profitability. This is immensely useful for creating a business case, and we have done that with companies, and the management clearly liked it, because now they not only have identified the risk, not only have they identified the interrelationship between the risks, but they also know to what extent these risks might impact performance. That clearly helps in creating a business case.